Hi, everyone. So today we're going to talk about linear correlation analysis. So really just the basics. When we're defining correlation, we are measuring the relationship between at least two variables. So when this is done with two variables, that's referred to as bivariate correlation. Our two variables are going to be our predictor variable and our criterion variable. Correlation has two major components. That's the strength of the coefficient and the direction of the relationship. And we'll talk about both a little bit more as we keep going. There are several different basic assumptions that need to be met when doing a correlation analysis. First, you must use interval or ratio level of measurement for both X and Y variables. This is referred to as parametric. There are non-parametric correlational tests that we can do, but we're going to focus on parametric just for this example. Typically, you have to have a large sample greater than 30 to run this kind of analysis. There needs to be normal distributions for both X and Y, and there needs to be homoscedasticity, which essentially just means similar dispersion when we're looking at the data on a scatter plot. So when we're discussing correlation coefficient, this is represented with Pearson's R. Values are going to range anywhere between -1 to +1, and we're looking at the absolute value of Pearson's R to understand the strength of our relationship. So we can have either a weak, medium, or strong relationship, once again, based on that absolute value of that score. And we're going to talk a little bit more about what each of these looks like when graphed. So when we're discussing a positive correlation, this is when both variables continue to increase. So if we're looking at the player wages and the goals scored of Premier League soccer strikers, typically players who are paid less might score less goals versus strikers on larger teams. They might score more goals and get paid more money. And so once again, this would be a positive correlation because when we have our line drawn, both continue to increase as continuous variables. So moving on, when we're looking at negative correlation, so this time we're looking at Premier League defenders, and similarly, players who get paid more are typically going to concede less goals. So for our hypothetical data, you have defenders getting paid a lot of money who are conceding 1 goal a game, 2 goals a game. Maybe for some of the smaller clubs that might end up getting relegated at the end of the year, they concede more goals, but also they're getting paid much less money. And so when we draw our line, it's going to look something like that. We will have outliers in certain circumstances, and essentially that could change our line. So maybe a player gets paid a lot of money, but they also concede a lot of goals. So they would typically play for Manchester United in this circumstance. They may be somewhere over here, and that would ultimately change our R coefficient when we introduce that data or look at the outliers. And then finally, a zero correlation. So this is not the same as a no correlation, but instead a zero correlation. So if we're looking at Premier League midfielders, player wages and goals scored, there's several different types of midfielders, box to box, holding, attacking. Their data will certainly be a little differently dispersed than strikers and defenders when, again, we're looking at goals scored or goals conceded. In this circumstance, our line looks something like this, which would represent a zero correlation linearly. And so the final point that I want to make is that causality cannot be implied with correlation. So Jadon Sancho on the left makes around 18 million pounds versus Mohamed Salah, who makes around 10 million pounds. Mo scores far more goals than Jadon Sancho, but Jadon Sancho makes far more money. So it's not necessarily because Jadon makes more money, he scores more goals, or because he scores more goals, he makes more money. In that circumstance, there is no cause and effect, which is, again, important to note. Thanks so much.